Hello everyone, welcome to my internship presentation. Today I'll be sharing with you what I learned and implemented during my internship on developing a smart washing machine system using the PIC16F877A microcontroller. This internship program is implemented by MHG Technologies. Household appliances have become essential in modern life, and washing machines are no exception. With advancements in technology, washing machines have become more intelligent, energy efficient, and user friendly. My project aims to create a reliable, flexible, and smart washing system tailored to meet diverse user needs. Key learnings from this internship program are C programming language, embedded C, and embedded systems. C is a versatile and widely used language for developing operating systems, applications, and embedded systems. It is low-level memory management. C provides direct access to hardware resources, making it suitable for systems programming. C code can be compiled on various platforms with minimal modifications. Embedded C is a variant of the C language tailored for developing embedded systems. Embedded C provides features and libraries specific to embedded systems such as interrupt handling, I/O operations, and bit level operations. It is also used for programming microcontrollers, microprocessors, and other embedded devices. Embedded systems are designed to perform specific tasks, often in real time, and are typically integrated into large systems or devices. These often use microcontrollers or processors as their core components. Embedded systems are used in various domains, including industrial control, automotive, medical devices, consumer electronics, and more. We also learned about LEDs in this MHG Technologies internship program. LEDs are semiconductor devices that emit light when an electric current passes through them. LEDs are widely used in various applications, including lighting, displays, indicators, and optoelectronic devices. LEDs offer advantages such as energy efficiency, long lifespan, and high reliability. This slide provides a comprehensive overview of the different categories of embedded systems, which are crucial in various applications, including washing machine simulations. Standalone embedded systems. These systems operate independently without relying on other systems for their functionality. They can be further divided into slave standalone embedded system. This type of system is designed to perform specific tasks under the control of another system or master device. It does not have the capability to operate independently. Independent standalone embedded system. As the name suggests, this system can function on its own without the need for external control or input. Real-time embedded systems. Real-time embedded systems are designed to process and respond to inputs in real time. They are critical in applications where timing and deadlines are crucial. These systems can be categorized into hard real-time embedded system, firm real-time embedded systems, soft real-time embedded systems. Hard real-time embedded system has strict deadlines and must respond to inputs within a specific time frame. Failure to meet these deadlines can result in system failure or catastrophic consequences. Firm real-time embedded systems also have deadlines, but missing them does not result in system failure. However, it can lead to degraded performance or reduced quality of service. Soft real-time embedded systems have deadlines, but missing them does not significantly impact the system's performance. These systems are often used in applications where some flexibility in timing is acceptable. This category includes embedded systems that do not fit into the standalone or real-time categories. They can be further divided into: network embedded systems are connected to a network and can communicate with other devices or systems. They are commonly used in IoT applications. Mobile embedded systems are designed for use in portable devices such as smartphones, tablets, or laptops. They are optimized for low power consumption and mobility. Hybrid systems combine different types of embedded systems such as standalone and network systems to create a more versatile and powerful solution. The slide provides a detailed classification of embedded systems, highlighting their characteristics, advantages, and applications. Understanding these categories is essential for designing and developing efficient and effective embedded systems for various industries, including washing machine simulations. Let's deep dive into the washing machine simulation program. As I said earlier, it is simulated on PIC16F877A microcontroller. The objective of the smart washing machine using PIC16F877A microcontroller project is to simulate a washing machine's functionality using this microcontroller and PICSIMLAB. The key features include customizable wash programs, fabric type selection, water level control, and real-time monitoring. As a brief, users can select from various wash programs and customize settings. The system optimizes wash programs. The key features include customizable wash programs, fabric type selection, water level control, and real-time monitoring. The tools that are used in the development of this system are MPLAB, X8 compiler, and PICSIMLAB. Here the brief about MPLAB. MPLAB X IDE is a comprehensive integrated development environment for developing and debugging embedded applications on microchips PIC microcontrollers. It provides a range of features including code editor, project management, debugger, and simulator. While X8 is a C compiler developed by Microchip Technology for programming PIC microcontrollers, it is designed to generate efficient and optimized code for Microchip's 8-bit PIC microcontrollers. The X8 compiler provides ANSI C compilance, optimizations, and support for PIC microcontrollers. PICSIMLAB is a simulator for Microchip's PIC microcontrollers. It allows you to simulate and test your code in a virtual environment, reducing the need for physical hardware and enabling faster development and debugging. PICSIMLAB provides simulation of PIC microcontrollers, support for various peripherals, and debugging capabilities. These tools are commonly used together to develop and test embedded applications on microchips, PIC microcontrollers. MPLAB IDE provides a comprehensive development environment, while the X8 compiler generates efficient code for the PIC microcontroller. PICSIMLAB enables simulation and testing of the code in a virtual environment, reducing the need for physical hardware and streamlining the development process. Let's talk about the PIC16F877A microcontroller. This microcontroller is a type of 8-bit microcontroller belonging to the PIC16F family of microcontrollers developed by Microchip Technology. This microcontroller has 8 KB of flash program memory 368 bytes of RAM data memory and 256 bytes of EEPROM data memory. It has a clock speed of up to 20 mHz and it operates at a voltage range of 4.2 to 5.5. This is the recommended operating voltage range for this microcontroller. Let's discuss about tactile switch. A tactile switch provides a tactile feedback when pressed. It's commonly used in electronic devices to provide a user-friendly interface for users to interact with the device. We have total 4 switches in this program. We used RB0, RB3, RB4 and RB5 switches, where the RB0 switch is used to monitor the door status. If we long press that button, the CLCD display says that door is open, please close the door. The RB3 switch used to navigate through different options or settings on the washing machine. RB4 is used to power on the washing machine. RB5 is used to pause or stop. This is the CLCD. CLCD stands for Character Liquid Crystal Display. It's a type of display used to display text, characters and systems. The features of CLCD are character display, multi-line display, backlight and easy to interface. The applications of CLCD are embedded systems, industrial control systems and consumer electronics. The usage of CLCD in this project is to display wash cycle status. It shows the current wash cycle, water level and other relevant information, and to provide user feedback, display messages and alerts to the users such as program complete or errors, and to display settings, show the selected wash program, water level and the other settings. Let's talk about timer and interrupt. A timer is a hardware module that generates a signal at a specific interval, allowing the microcontroller to perform tasks at precise times. In the washing machine project, the timer can be used to control the duration of each wash cycle, ensuring that the machine operates efficiently and accurately. Where interrupt is a signal to the microcontroller that an event has occurred and requires immediate attention. In the washing machine project, interrupts can be used to respond to button presses, timer overflows, or other events, enabling the microcontroller to react quickly and efficiently to changing conditions. Let's discuss about buzzer and fan. The buzzer is an audible alert system that sounds after the completion of the wash program. It provides a notification to the user that the cycle has finished, ensuring they are aware of the status. The fan is a ventilation or cooling component that runs when the system starts. It pauses during completion of the wash cycle and also when the pause button is clicked. This block diagram illustrating the connections between various components. The diagram is divided into two main sections. The left side features input components, while the right side displays output components. Input components. RB4 is used to power on the washing machine. RB3 is used to navigate or select particular washing machine program or water level. RB5 is used to pause or stop. RB0 is used to monitor the status of the washing machine. Output components. Fan is responsible for controlling the fan's operation. CLCD displays information on the washing machine's LCD screen. Buzzer produces sound signals to alert users of various events. Microcontroller. Microcontroller serves as a central processing unit, connecting all input and output components. It receives input from the left side components and sends output signals to the right side components. In summary, the block diagram provides a clear visual representation of the washing machine simulation's architecture, highlighting the relationship between input components, output components, and the microcontroller. Now, let's take a look at the project demo. This is PICSIMLAB. It is used to code embedded C language. These are the header files and source files in C language for washing machine simulation. Let's build the program. Now the build is completed successfully. Let's open the PICSIMLAB application. Now we have to select PICGenius board and PIC16F877A microcontroller. Now we need to load the hex file. Let's click on file option and choose the washing machine hex file. Go ahead and click RB4 switch. This will initiate the washing machine program and displays wash programs list. This is the list of washing machine programs. Now we have to select any of the wash program to proceed further. It will take us to water level screen. On the screen we have to select the water level. We have low, auto, medium, high and max. This will direct us to start stop screen. If we click on stop option, it will get back to wash program screen. Now just follow the previous steps and click on the switch file start option. It will show the details of what we have clicked and start running. We can pause the process by using RB5 switch. We can clearly notice that fan is stopped running and the timer is also stopped. If we click on RB0 button right now, it will alert us, door is open, please close the door. After the completion of the program, it displays program is completed and makes buzzer sound for 2 seconds. This is how we can run a washing machine simulation program. In conclusion, my internship project successfully demonstrated the development of a smart washing machine system using the PIC16F877A microcontroller. The system features are real-time control, seamless integration with hardware peripherals, and an intuitive user interface. I'm confident that the skills I've acquired during this internship will be useful in my future endeavors. Thank you for your attention, and I hope you enjoyed this presentation.